Welcome to the deep dive. Today we're plunging into an idea so fundamental, it might just redefine how you see, well, everything. What if, for centuries, science has inadvertently engaged in a kind of grand mislabeling?
Right.
What if, at its core, countless scientific concepts are actually just different names for the same underlying phenomenon?
Motion.
That's the bold hypothesis we're exploring today. It's called motion theory.
Motion theory, okay.
And it proposes this singular, unified reality of motion that underpins absolutely everything, from the tiniest quantum particles to the cosmos and even consciousness itself.
Wow.
It's a pretty profound shift in perspective, definitely challenges our usual ways of thinking.
Our mission today isn't about dismantling established science, though. Far from it.
No, absolutely not.
Instead, we want to look at that incredible body of knowledge, but through this, well, revolutionary new lens.
Yeah, the goal is clarity. To find some surprising insights, maybe, and help you cut through all the information overload we face, so you can really see the universe differently. Let's unpack this core idea first.
Okay. So the foundational principle of motion theory is basically that every phenomenon we observe, physics, biology, even our own thoughts, it's all ultimately this a form of motion.
Okay.
The challenge, and this is what we call the language trap, happened when humans started naming the different appearances of motion. And we accidentally let those labels become, separate realities in our minds.
It's like looking at different ripples in a pond, small, fast ones, big, slow ones, and giving each one a totally unique, fundamental name, forgetting they're all just water moving.
Exactly that. It's a great analogy.
Before we dive into specific examples, when we say motion here, what are we actually talking about? Because it sounds like motion theory has its own sort of specific way of using the word.
That's a good point. Yes. When we say motion, we mean organized patterned movement, not just something flying from A to B.
Right.
We're talking about structured motion. Any stable setup or repeating pattern of movement. Think of like a spinning top or the way an electron orbits. That kind of consistency.
Structured motion. Got it.
And we'll also talk a lot about synchronization. That's just when motions line up or become compatible. It leads to stability or what looks like attraction.
Okay.
And then there's motion resistance, which is basically how hard it is to change a motion pattern.
Like inertia.
Sort of, yeah, but viewed through this motion lens. These are the key ideas.
Right.
Structured motion, synchronization, and motion resistance.
That sets a really crucial foundation. Okay, so this theory seems to reframe some huge concepts in science. Let's start with one we all sort of feel, but physics makes complicated time.
Right.
Conventionally, we often think of time as this weird force or a substance, maybe a fourth dimension. And that leads to confusing stuff like time travel, time dilation.
Yeah, and a key insight here is how motion theory just cuts through that complexity. It says time isn't a separate thing at all.
Okay.
It's simply motion counted.
Motion counted.
Yeah. A second, for instance, isn't some abstract slice of a dimension called time. It's just a standard unit of motion. We use the vibration of a cesium atom, right? That's motion.
So the clock is just tallying movements?
Exactly. It's counting motion, not measuring some independent thing called time. And this view, it actually dissolves a lot of the paradoxes.
How so? Like time dilation?
Well, time dilation seems weird if you think time itself stretches or shrinks. But if time is just counted motion, then dilation is about the rate of motion changing in different frames of reference.
So the clock, the internal motions in a fast-moving object, just runs at a different rate compared to a stationary one.
Precisely. The rate of counting motion changes, not time itself.
Okay, that's a big shift. It's about the counting, not the fabric. So if time is counted motion, and you mentioned motion resistance being related to mass, what about energy? Usually seen as the capacity to do work, right?
Right. And from the motion theory view, all forms of energy are simply structured motion under constraint.
Structured motion under constraint.
Yeah.
Okay.
Whether it's kinetic, tensile, thermal, electrical, it's all about how motion is organized and what it could potentially do. Even EMC squared fits perfectly. Mass M is motion resistance, how hard it is to change motion. Energy E is the potential for structured motion to happen or change.
So the different forms of energy are just different ways motion is set up or restricted.
Exactly. Kinetic energy is obvious. Active motion. Potential energy is like stored or constrained motion ready to be released.
That makes a lot of sense, yeah. See it as a state of motion, not a separate substance.
Yeah.
Okay, what about force? We learn it's this thing that causes change in motion.
Yeah.
You push something, it moves because of the force.
But what if force is just our label for what happens when motion meets resistance, or when motion patterns interact? When you push a wall, is there really a separate force entity appearing? Or is it just a redistribution of motion through you, the wall, the ground, a patterned interaction of motion flows?
So Newton's laws would describe motion interference.
Essentially, yes. The consistent patterns of how motion interferes, redirects, or combines, not the action of some abstract force thing. It's motion interacting with other motion.
Wow. Okay, so by redefining time, mass, energy, force, it all seems to come back to motion and its resistance. We're already seeing a kind of simplification.
That's the idea.
So how does this help with more complex stuff, where things interact in, really interesting ways? Let's talk gravity. Conventionally, it's space-time curvature, or a force between masses, planets pulling each other.
Right. But if we bring in that idea of synchronization, motion theory suggests gravity isn't a pull at all.
Okay, what is it then?
It's the natural convergence of structured motion towards zones of higher synchronization density.
Higher synchronization density.
Definitely.
Like more organized motion.
Exactly. Think of it less like attraction, more like less organized motion getting sort of drawn into rhythm with larger, more stable motion patterns.
So planets, stars, black holes, they're not just massive, they're highly synchronized nodes of motion.
Incredibly stable, yeah. And other structures, less synchronized, tend to naturally lock into their patterns. That looks like attraction.
Convergence towards synchronization.
That's gravity at its heart.
That's a really powerful image.
Yeah.
Motion trying to find its most stable, synchronized state. Does this synchronization idea also work for something like light, which we always struggle with? Is it a particle? Is it a wave?
Well, motion theory offers a way out of that duality. It proposes light is neither, really, not in the standard way. It's structured motion, but transmitted through space as a kind of synchronized rhythmic interaction.
A synchronization ripple.
Yeah, think of it like that. When an electron changes its motion state, it doesn't shoot out a particle. It vibrates a specific motion pattern outwards.
Like a ripple in a pond, but a ripple of synchronization.
Exactly. And that ripple looks like a wave if you observe it spread, but interacts like a particle at a specific point where its synchronized pattern gets absorbed or emitted.
And it's constant speed.
That would just be the inherent speed limit for how fast these synchronization patterns can transmit through space itself.
A synchronization ripple.
Yeah.
I like that. It feels clearer. Okay, what about charge? Positive, negative. They seem so fundamental and opposite.
Here, they're seen as results of asymmetric motion patterns.
Asymmetric.
Yeah, like an electron is maybe a motion loop with a specific imbalance, a tilt in one direction. A proton is a different loop, maybe tilted another way.
And they attract because...
Not because of some invisible force field, but because their imbalances kind of complement each other. They can achieve a more stable, complete synchronization by combining their motion patterns across that gradient.
So charge is like a directional motion imbalance looking for balance.
Looking for synchronization, equilibrium, yeah.
And heat, usually just called a form of energy related to temperature.
In this view, heat is simply disordered micromotion.
Jiggling.
Pretty much. Atoms and molecules moving randomly out of sync. The second law of thermodynamics, about entropy increasing, that just describes motion's natural tendency to smooth itself out, to spread from ordered states to disordered ones, seeking uniformity.
So my coffee cooling down is just its fast jiggling motion spreading out into the slower air molecules.
It's sharing its unsynchronized jiggle, trying to reach equilibrium. Heat is just unsynchronized internal motion.
It's really striking how these things, gravity, light, charge, heat, which seem so different, all seem to trace back to motion, synchronization, resistance.
Different kinds of motion, different constraints, different patterns.
Let's push this further. Quantum fields. There are dozens. Higgs, electromagnetic, gluon. How does motion theory see these? They seem like fundamental stuff.
Well, the insight here is that maybe they aren't stuff either. Maybe they're essentially motion mappings.
Motion mappings, like charts.
Kind of. A field isn't seen as a separate entity floating in space, but more like a model of potential motion outcomes. It's a structured set of rules, probabilities for how motion could behave or interact in a certain area.
So instead of dozens of distinct fields.
Maybe they're all just different ways of describing the inherent rules and probabilities of motion. They're encoded motion probabilities. It could potentially simplify things like the standard model, showing an underlying unity.
Okay, descriptions of potential motion, not things themselves. Now, shifting gears completely. Consciousness. This is often talked about with neurons, signals, brain patterns. How can motion account for something seemingly so non-physical?
Well, at its core, consciousness is physical. It's chemical motion, electrical motion.
Right, the brain activity.
But then it's also the incredibly complex reflective motion within that system. Consciousness, in this view, is a high-level recursive motion loop.
Recursive, meaning it loops back on itself.
Exactly. It processes, adapts to, and even models its own structure and activity. The hard problem, how physical stuff gives rise to subjective feeling, isn't magically solved, but it's reframed.
How so?
We start asking different questions. What kind of recursive motion processing results in self-awareness? Consciousness becomes fundamentally a highly sophisticated form of recursive motion processing.
Our inner world as a dance of motion. That's profound.
And what about biology? Protein folding, DNA unwinding, cells dividing, these are very specific processes.
And they are all motion. But it's motion constrained by evolutionary optimization loops.
And evolution constrains the motion.
Yes. Every organ, every process is a structured motion adaptation shaped over eons to support the larger motion loop of survival and reproduction.
Yeah.
Life itself is this incredibly complex, self-sustaining motion network.
Motion constrained by the need to survive.
Every biological function, from your heart beating to you having this thought, is an optimized, constrained motion sequence. Okay, even life itself is motion upon motion. And chemistry. Bonds, reaction rates, stability. That seems very specific down at the atomic level.
Right, but chemical bonds aren't some mysterious glue. Fundamentally, they are patterns of motion synchronization between the electron shells of atoms.
So atoms bond when their electron motions sync up.
Exactly, leading to a more stable, lower energy, less frantic motion state. Reaction rates become motion transfer speeds between molecules. Stability is about motion loop compatibility. Do the motions fit together well?
So chemistry is like orbital motion architecture.
That's a great way to put it. It's how the motion patterns of atoms fit together.
So, okay, from fundamental particles, fields, forces, energy, all the way through chemistry, biology, even consciousness. This motion view seems to touch everything. But why did we miss this? Why did science fall into this language trap, this grand mislabeling?
Well, it was almost necessary. Science had to name things as they appeared.
You see something fall, you call it gravity. You see a spark, you call it electricity.
Exactly. Early observers saw distinct phenomena, falling apples, sparks, cells dividing, and gave them distinct labels because they looked different. The problem was when the labels took on a life of their own.
The label became the reality. The map replaced the territory, as you said earlier.
Precisely. Each new label became a separate thing to study, often in isolation within its own field.
And because physics, chemistry, biology often developed independently, each with its own vocabulary.
It led to this fragmentation. Think of all the terms. Entropy, voltage, spin, frequency, flow, field strength, torque, turbulence, gravity, heat, inertia, charge.
From this perspective, they're all just variations on motion.
Variations of structured motion, synchronization, resistance, interference. But our language made them seem like fundamentally different concepts.
So language helped us describe things, but it also accidentally hid the underlying unity. Made motion seem like just a background effect.
Exactly. We focus so much on the specific appearances that the language solidified those appearances into separate realities, obscuring motion as the root principle.
Okay, so what's the fix? We're not suggesting throwing out centuries of science, right?
Absolutely not. Motion theory doesn't discard anything proven. It reorganizes it.
Oh.
The approach is to strip every concept, every label, back to its core underlying motion description. What is actually moving? How is it constrained? How is it synchronizing?
And then rebuild from there.
Then rebuild a unified framework from that motion-based foundation. The goal isn't just renaming things, it's reframing for clarity, for deeper insight. Imagine the connections we might see.
This is where it gets really exciting, I think. If you start looking at everything as motion structured through constraints, things might suddenly make more sense. Like dark energy, its huge mystery pushing the universe apart faster and faster. Could it just be unaccounted synchronized motion on a massive cosmic scale? Large-scale motion patterns we haven't grasped yet.
It's a possibility this framework opens up. Or particle spin, it feels weird, non-intuitive, but maybe it's not literal spinning. Maybe it's a looped motion axis, a stable, quantized pattern of internal motion.
So this perspective shift helps us ask better questions.
Exactly. Instead of just asking, what is this thing called? When you start asking, what's actually moving here? What's the constraint? What's the sync rate? What are the boundaries of this motion loop?
Those feel much more fundamental, replacing labels with questions about the underlying dynamics.
It pushes towards clarity, away from just classification.
So, wrapping this up for you, the listener, this deep dive has looked at this pretty radical idea that science might have sort of accidentally mislabeled motion thousands of times.
Yeah, creating a view of reality that's maybe more fragmented and complex than it needs to be.
The central idea we've explored is that motion, structured, synchronized, constrained motion, is the unifying root beneath absolutely everything.
And if we really lean into this motion renaissance and start trying to understand science from motion upwards, well, we might not just understand the universe differently.
We might finally see it clearly for the first time. Appreciate the elegance under the complexity.
That's the hope, seeing the simple, unified dance beneath it all.
And when you really think about it, maybe that's how a universe is actually built, isn't it? One motion at a time.